Bismillahirrahmanirrahim. In this video, we'll solve exercise problems 6.4, 6.5, and 6.6 of chapter 6.12, Operation of NPN Transistor in Active Mode. Okay, so let's see what is 6.4. We have to calculate B for two transistors for which alpha is given. For the next part is for collector currents of 10 milliampere, find the base current for each transistor. So this is simple. We know the formula for beta and alpha radiation. So this formula we'll use. Simply plug in the values for alpha 0.99. We get this term, and which is equal to beta 99. And similarly for alpha 0.98, plugging in the value, we find beta to be 49. Now the next part, for collector current 10 milliampere, we have to find the base current. So we'll use this formula. Again, plugging the value of IC 10 milliampere, and beta for this case is 99. So we plug in 99. So for the first case, the base current will be 0.1 milliampere. And in the second case, instead of beta 99, now we'll plug in beta 49 from here. And so the base current will be 0.2 milliampere. Okay, the next question is, for a transistor, IS is given and beta is given, and it's conducting a collector current of 1 milliampere. You have to find VBE, find ISE, and find ISB. Okay, so we can take help from these formulas. So let's start. We'll use this formula for collector current. Manipulating, bring it to the other side, taking logarithm on both sides. So we get, when we take log, this E terms goes, so we get VB over VT, log natural IC over IC IS, and from here VBE is VT into log natural IC over IS. Now we plug in the value. We know that VT is 25 millivolt at normal room temperature. IC was given here 1 milliampere, and IS is also given 10 to the power minus 16 ampere. So VBE can be calculated to be 0.748 volt or 748 millivolt. So this is the first part. Now let's go to the second part. Now we know we have to calculate ISE. This is IS, which passes through the collector current, or which is the element of the collector current from here. And so to find ISE, we have to take help of the formula of IE. So we can write that ISE is beta plus 1 divided by beta and IS instead of IC. So this will be the formula for calculating ISE. Plugging in the value of beta 100 and solving, we find ISE to be 1.1 10 to the power minus 16 ampere. Now the third term, ISB, we know that IB is IC over IB, so ISB can be written as ISB is IS over B, because IS is the element of IC. and again now plugging in the values, this becomes 10 to the power minus 18 ampere. And this is the answer given in the book, which is very close to what we have calculated. Okay, the last question is that for circuit in figure 6.61 analyzed in example 6.1 in the book, find the maximum value of RC that will still result in active mode operation. Okay, first of all, we should be clear about the conditions for active mode. We know from this diagram that this has to be forward bias, so VBE has to be forward bias, and VCB has to be reversed bias. So N will be connected with the positive battery and P will be connected with the negative battery. So this is the battery arrangement that we should have for the circuit to be in active mode. That means VBE has to be greater than 0, this one, and VCB also has to be greater than or equal to 0. Now in the symbolic form, this is the representation. So from here we can use KVL, going from here minus VBE, minus VBE, minus VCB, minus VCB, and plus VCE equal to 0. And so we can say that VCB is equal to VBE minus VCE minus VBE. Okay, now VCB has to be greater than 0. That we found VCB has to be greater than 0. That means this term VCE minus VBE has to be greater than 0. So VCE minus VBE has to be greater than 0. Now from example 6.1 solved in the book, we found out VBE to be 0.69 and the collector current was 1 milliampere. So we'll use these two terms. Now to find VCE, let's look at this diagram. We can take KVL. This is VCE from collector to emitter. This is the voltage drop across the resistance, and here is the supply voltage VCC. So we can take help of KVL again. We're going from this side, so minus VCE, minus ICRC, and plus VCC. So the battery is actually connected here. So this is the KVL, and from here we can find VCE to be VCC minus ICRC. So this actually you have to remember, this is very frequently we'll be using this term, that VCE is VCC minus the voltage drop here. That is another way of finding this. Okay, so we can replace VCE by VCC minus ICRC and minus VBE. This has to be greater than 0. Plugging in the value, VCC from here is 5 volt. So 5 volt minus 1 milliampere is IC, and RC we need to find the maximum value here. VBE is minus 0.69. So from here, solving, we find that 4.31 has to be greater than 1 milli into RC, or we can say that RC has to be less than, when we bring it on this side, it has the sign changes direction. It is less than 4.31 divided by 1 milliampere. So that means it will become 4.31 kilo ohm. So this is the value maximum that we can go. In the example 6.1, we had taken RC to be 3 kilo, but we now find out that up to 4.3 kilo ohms, this circuit will remain in the active mode. I hope this gives you an idea as to how to solve this type of a problem. Thank you very much.